So let us start with Yogesh. Yogesh, just give your introduction.
Yes. Good evening, sir. I'm
Uh,
Yogesh Roshan. I have completed my M.Tech from IIIT Gwalior. From 1 year, I'm doing professionally. I'm design verification engineer from 1 year. I'm design. I have started my career in Bit Silica as a design verification engineer in 2018, in 2022. Sorry. In 2022, around August 2022, I have started my career in the Bit Silica, and I have good hands-on system Wedlock UVM. Also, I have good knowledge of AXI, AHB, APB, all AMBA protocol, and I also have kind knowledge of IP verification also.
okay,
So
great. So which projects you have done?
I have completed AXI, AHB protocols. Also, I have a good knowledge of I2C, SPI, UART.
Mhm. So hi Girish. Yeah, Girish, the next comes to Avdesh. Hi Avdesh. Oh hi Avdesh. Yeah, Avdesh.
Hello.
Just give your introduction once.
Hello. My name is Avdesh Chauhan. I have completed my dual degree integrated course BTech plus MTech in VLSI and BTech in Electronics and Communication Engineering from Gautam Buddha University, Greater Noida.
Okay.
I have done internship in diagnosis from February 2022 to May 2022, and from after onward, after completing my degree, I joined VLSI for all as a trainee.
Okay, fine. So right now, which projects you have done till now?
Till now, I have completed APV and doing SPI, I2C, and
Hmm.
UR.
Oh hi Kailash. Kailash, give your introduction first.
Yes. Good evening, sir.
Good
I
evening.
am Kailash Kuswa.
Hmm.
I born and brought up in Uttar Pradesh. I did my graduation in BTech Electronics and Communication from Dr. APJ Abdul Kalam Technical University, Uttar Pradesh,
Hmm.
and also I did my post graduation
Hmm.
in MTech Microelectronics from Dr. APJ Abdul Kalam Technical University
Hmm.
in
So
Uttar
okay,
Pradesh.
fine. So you have done the masters. Which year masters?
Microelectronics.
Okay. And okay, which project you have done till now?
Sir, APB and FIFO.
Okay, fine. Then we have Sudhir. Hi Sudhir. Sudhir, give your introduction first.
Hi sir, my name is Sudhir. I am hardworking engineer graduate specialized in electronics and communication engineering. Overall CGPA is 7.71. Along with my degree, I completed training in the Central Institute of Tool Design. Now I am pursuing MTech in NITK Surathkal in VLSI domain.
Okay. So Girish will be your interviewer today. So Girish, turn on camera and just ask the basic questions of STA, digital and value. That's it. 3 subjects only. And ASIC design flow, FA design flow, basics. Okay. So we can start with directly with the questions. I have taken the introduction already. All are from DV. Uh, your voice is not coming here.
Yeah, sorry. Yeah,
Now it is coming.
we'll start with Kailash.
Yes, sir.
Turn on the camera. Okay, we'll start with the digital.
Yes.
So, what's gate? Define gate.
Gates. There are 4 types of gates. Many types of gates. Basically, basic gates, NOT and OR gates.
I'm not asking the types. I'm just asking you to define gate. What do you mean by a gate?
Okay, next
Sudhir.
question.
Next, sir.
Sudhir, the same question for you.
Abdesh, meanwhile, you can ask write the difference between latch and flip-flop. Just write it on the paper and we will discuss.
Sudhir, what do you mean by gate? Sudhir, you are on mute. Unmute yourself and speak.
Yes, sir. Am I audible?
Yeah, you're audible. Continue.
It is a design block which is used to implement any circuit.
So, just that much?
Sir?
Only that much? That's what you define a gate as?
It will perform any logic functions based upon our wish, based upon our interest. The gate will be designed. It means based upon our function what we need, like AND means AB function, like that, OR means A plus B, like that.
Fine. Yogesh, define a flip-flop.
Flip-flop is a age-sensitive device.
Device.
Yeah. Actually,
Okay.
it's a
fine.
age-sensitive storing element. Means it will trigger the element. It will store at the aging of the part, and it's at a passage clock or at negate clock. It will store the element. So for the purpose of storing, we use flip-flop. There are multiple flip-flop, D flip-flop, JK flip-flop, RS flip-flop.
So, what do you mean by a latch?
Latch is a level-sensitive storing element. It will miss if you're in latch. You have to give command like that. If your signal is high or if your signal is low, then only you have to store the element, store the signal, and hold the signal value like that. While in flip-flop, at the edge detection, you will hold the value.
Can you build a flip-flop using latches?
Okay.
No, I'm asking, can you build a flip-flop using latches? Yes or no?
Sorry. Yes. Yes.
Okay. Can you build a latch using flip-flop?
Yes, we can. We have to take 2 latches and connect it in. We have to take 2 latches. And
that's
for
okay.
first latch, we have to take
understood. No. I'm asking, can you build a flip-flop using latches? That question, that was answer right, okay? Can you build a latch using a flip-flop?
Can we build latch using flip-flop?
Latch functionality using a flip-flop?
Latch functionality using flip-flop. I never did this, but we can do flip-flop by using latch.
Okay. Same question for you, Avdesh.
Hello.
Abdesh have one question, right? I have given his one question. You can next.
Yeah. Tell me the difference between latch and flip-flop.
Yes, latch is a level-sensitive device. Circuit or flip-flop is a edge-sensitive device. As latch being level-sensitive, it is prone to noises or distortions. It carries distortion. It also carries noises and distortions with as the propagation. On the propagation, while as flip-flop is edge sensitive device, so it does not prone to errors, noise, and latch has less circuitry, so it consumes less power, and flip-flop have more circuitry than latches, so it consumes more power.
So according to you, latch consumes less power and the flip-flop consumes more power, right?
Yes, because circuitry is more in flip-flops.
In flip-flop. Okay, then as per your analysis or whatever your statement, even a flip-flop is built by a latch, right?
Yes.
So it should consume less power. Why does it consumes more power than when compared to latch?
No. Flip-flop is made up of latch circuitry plus some other gate circuitry is equal to flip-flop. So
Sure?
it's yes, in latches like
No,
NAND
no.
latch.
You said in flip-flop you have a latch circuitry plus additional circuitry, right?
In
You
flip-flops,
sure about that thing?
yes, as far as I have read, I have made.
Then can you analyze how a SR flip-flop is built?
Yes, as a flip-flop using NAND gate, uh,
No. The internal circuitry of
internal
a SR flip-flop.
as internal circuitry of SR latch and flip-flop. So
You're
yes,
not getting my point. You
this
said that latch
sorry,
are.
sorry,
I'll clear you a question.
I'm little confused. You are asking me for flip-flop, SR flip-flop, and I am telling you SR latch. So I am little bit confused in this. So I will clear that after.
Okay, fine. We'll move to the next question. Okay. What do you mean by a mux,
Yes.
Avdesh, sorry.
Yes, MUX is a combinational circuit in which we multiplex, in which we have multiple outputs, and for that multiple outputs we have we have multiple inputs for those multiple inputs we have only one output at one time
Okay.
at a time.
Okay. So how does your mux operate?
Yes, if we have two select line, then
Hmm.
for those two select lines, to the power and to the power 2, there will be to the power 2 equal to 4 inputs, and for those 4 inputs we will get corresponding one output at a time.
So at what would be the least input and the least what would be the least input mux, the basic mux, what you can have a
Yes,
least.
2 cross 1, we make 2 cross 1 max.
So
Or
what would be your
as yes, sir, can you repeat?
what would be your select lines?
Yes, only one select line will be there, one select line and 2 inputs for this.
Okay. Yogesh, for you, the next question. What's the difference between the mux and an encoder?
Mux has a select line while encoder has no select line. This is the difference. But also, encoder convert applied information signal into the coding digital bit stream.
Okay.
Yeah,
So
for the
what's
communication
the employment of
we use
mux? Yeah.
for communication purpose we use it at the transmitting end. While multiplexer is like a data selector, um, for combination circuit that use several data input to generate only single output. For this purpose, we use MUX.
Okay, fine. Then what about the decoder and demux?
DMUX is just the inverse of MUX. It's a combination circuit that is single input that can be directed throughout the several outputs.
How can you direct single input through several outputs?
Means DMUX include a 2 raised to power n output in n select line, while single input like that.
So you are saying that one input will be provided to the all the outputs based upon the select lines.
Yes. That will be one Boolean equation kind of.
Okay, fine then.
For data means address in actually for address locator we use this decoder multiple times.
Okay, fine. For you, Sudhir.
Yes, sir.
Okay. If you have to design a counter, what are the needs
Okay.
you have to? If you have to design a synchronous counter, what are the inputs or what are the elements you need? If you have to design a asynchronous counter for mod 4,
Okay, sir. In synchro. I'm unable to hear, sir.
if you have to design a counter, a synchronous counter. Can you hear me? Are you able to hear me?
No, fine, sir.
Okay, listen carefully.
Hello,
If you have to design a yes, Avdesh.
yeah, sorry, sir. So can I connect to my second computer? And there is no camera on that, so I am joining because this laptop is battery
Okay,
is
fine.
draining.
No problem. Just do it fast.
Okay, thank you.
Yeah, Sudhir. The thing is, if you have to design a counter, a synchronous counter.
Perfect.
Sudhir, there might be an issue at your end.
Sir, not audible perfectly.
Sudhir, you can disconnect
Every
and reconnect. You can reconnect. No problem. So, Yogesh, just write the equation for the setup time and hold time meanwhile.
Sir.
Okay.
Kailash.
Yeah,
Should I define setup time and hold time?
Yeah, you can write on
Yeah.
the paper. Just equation. This equation.
Equation.
Sir, can you?
Sudhir, your voice is completely distorted. You can either leave the meeting. You can join with a better voice. I'm removing this Sudhir. Yeah, Kailash. Kailash. Yeah, we can go to the Kailash.
Yeah, Kailash. Yeah, if you have to design a counter, if you have to design a synchronous counter and an asynchronous counter, what are the elements you need to design that counter? And I'm giving you to design it for a mod 4 counter. Means mod 4 counter. Yeah. What are the inputs or elements you need for them?
Sir, there are two flip-flops and for a synchronous counter.
I'm asking you to design a mod 4 counter,
Yes,
synchronous counter and an asynchronous counter. What are the elements you need to design them?
elements. Sir, I can't explain.
No, see, if you are going to design a counter,
Yes,
you
sir.
need at least basic things, right? What are the things you need? You might need some things. Those things will help you design a counter. What are those?
Sir, first of all, flip-flop.
Okay, which flip-flop?
Sir, JK flip-flop.
Okay, for what? Synchronous or asynchronous?
Sir, for synchronous के single one common clock are
Okay.
provided, and asynchronous के लिए for asynchronous different clock. First mod 4.
No, I'm not asking you to explain the design. What are the things you need to design? How many flip-flops you need? Which flip-flop you need?
Sir, JK flip-flop and clock and gates, logic gates, and
Tell me for synchronous mod 4 counter, what are the inputs? What are the elements you need?
sir, for JK flip-flop, we have two inputs and one clock.
I'm asking about the flip-flop, Kailash. Try to understand the question. I'm asking you to explain the inputs or define the inputs that are needed to design a mod 4 synchronous counter? If you know, you can tell yes. If you don't know, it's okay. We'll pass it to the next person, and you will get a new question.
Sir, next question.
Okay, be like that. Okay, fine. The same question goes to Avdesh. If you have to design a counter, mod 4 counter, synchronous and asynchronous, what are the inputs you need to design? Start with the synchronous and then go with the asynchronous.
Okay, sir. Mod 4 counter means it has 4 states. It means we need 2 flip-flops. And as it being synchronous, we will give a single clock to both the flip-flops.
You need 2 counters. Is that enough, Avdesh?
Yeah, yes, sir. If it is 4 with counter, we need to connect. We need to connect output of the last flip flop to the first flip flop.
Okay. So by that you will reach the synchronous counter.
Yes, synchronous means we will give same clock to the both flip flop at the same time.
Fine. Okay. Now, okay. They should be on mute. Whenever I ask you the question, you answer. Okay.
Okay.
Yeah, Yogesh, you tell the answer for that setup and hold the equation.
Setup time is minimum time interval prior to the input signal, prior to the clock signal, while hold time is the minimum time interval after the clock age signal, like that.
Avdesh, be on mute. Avdesh, be on mute. You have a lot of noise in your. Yeah, Yogesh, continue. Sorry.
So if you have passage or negate, so before the age of the signal for a minimum time interval, your signal should be stable. If your signal is not stable before the age of the signal, then you will get setup time violation. And after the age of the clock, your signal should be stable for minimum time interval. If your signal is not stable meanwhile, then you will get hold time violation. If you get a setup time and hold time violation, then your signal will be go to metastability. Metastability means you will not get your output as a predicted.
Fine. Okay, how can you resolve a setup time violation?
For that purpose, we have to there is a method striking at that moment. For that purpose, we have to add the flip flop. To flip flop, we have to add the
for setup to fix the setup violation.
For setup violation, we are actually to avoid the setup violation and hold time violation, we are using the clocking.
Listen to me, Yogesh. Listen to my question correctly. You have a setup violation. You have to what are the things you are going to follow to make sure that you are going to fix the setup violation? What are the steps you are going to do to fix the setup violation?
To fix the violation, we will take care that our signal is not getting changed before the input signal. For that purpose, we will use the clocking block as encoding. Digitally, I am not getting the method that reduced.
Kailash, the same question for you. If you have a setup violation, what are the steps you are going to follow to minimize the setup violation or bring it to an acceptable range? What are the steps you are going to follow to fix the setup violation? Kailash?
Hello.
Yeah. Did you got my question?
Yes, sir. Sir.
Yes, Kailash.
Sir, not revised this topic.
Okay. Avdesh, same question for you. If you have a setup violation, what are the steps you are going to follow to fix the setup violation?
So for that we can, so as far as I have done in physical designing tool, I have used earlier. In that, we used to use another device for the same structure, like changing the device for having more setup time, or we can use we can reduce the clock to queue delay of the circuit.
Yeah, how would you do reduce? You can't reduce the clock to queue delay directly, right? You have to follow some steps.
Yes, sir, I have read two clock synchronization synchronizers we use.
Okay.
Yes, three clock synchronizers also used in for these.
Okay, fine. So you are going to you are going to work on synchronization and flip flops to reduce the setup.
Sorry, sir, I have not so much clarity. I will read that again.
Okay. Next question goes to Yogesh. Be on mute, Yogesh.
Okay.
Yes, sir.
Yeah, Yogesh. So if you have a setup violation and a hold violation on your chip, after manufacturing, you have got to know that you have a setup violation and a hold violation on your chip. So can you still use your chip or not? If you can use,
Yes, we
why?
can.
If not,
Yes,
you
yes,
can't.
yes, yes, we can use, but you will get the metastability condition kind of metastability. That means that if you are predicting your input that at the
Got it.
POSIX clock,
Got it. Got it. Okay,
at
if you
POSIX
have a
clock,
setup violation, but if you have a hold violation, if you have a setup violation but not a hold violation, hold is fixed but only setup violation is happening, can you still use the chip or not? Justify for each.
yeah,
Your
your setup violation means there. Uh, at the changing time, your input will, your output will behave not wisely, not correct as you want. But as you don't have hold time violation, means that your signal is holding correctly. So after a few moments, you will get correct output. This is the meaning.
No, I'm not asking about the meaning. Try to understand my question, Yogesh.
Okay.
If you have a setup violation in your chip after manufacturing, only setup violation, no hold violation. Hold is fixed. You should not worry about the hold only. You can consider hold as fixed. You have a setup violation. If you have a setup violation in your chip, can you use your chip or not? If you can use, why? If you can't use, why? Justify your answer.
If you are to use the chip, then it will get the error at the means changing the
No. You are
at
not
the all clock.
understanding my question, Yogesh. Try to understand my question. What I'm saying is,
We cannot
you
use,
have a
sir, as
setup.
our
Yes or
desired
no?
output you will not get.
You can't use if you have a setup violation.
Yes, sir.
Okay, if you have setup violation fixed, but you have a hold violation, can you use your chip or not?
Then also we cannot use, sir.
Okay,
As if
fine.
you want 100% accuracy in your chip, then you cannot use
See,
that kind
I'm
of.
talking about use. Can you use or not? That's the only thing. I'm not worried about 100% accuracy. I'm not worried about anything. Can you use it to at least employ something in your chip? Can you use that chip to employ something or not?
Yes, you can use. Why cannot? It's only the for a moment. It is a issue, not for a long time.
Understand my question. Avdesh, continue.
Yes, sir. Sir, it depends because I have the equation capital T. Sorry, please. Capital T is greater than or equal to setup time plus clock to Q delay plus delay. So yes,
Avdesh, listen to me. If you have a setup violation and
yes.
hold violation is fixed, there is no hold violation, but you only have a setup violation. Can you use your chip or not? If you can use, why? If you can't use, why?
So if after calculation, if that equation satisfied, we can use. If after the setup time violation and the equation does not hold, we can't use the chip.
I'm telling you one thing. Try to understand. You have a chip that is already manufactured. Okay.
Yes.
Okay. After manufacturing, got to know that there is a setup violation in your chip. Now you can't alter anything. Can you use that chip or not? If you can use, why you can use, how you can use. If not, how you can't use, why you can't use.
Sorry, sir.
Hold, the same thing goes for the hold. Can you answer the whole thing?
No, sir. I will look into that deeply.
Kailash, can you answer this?
No, sir.
Okay, Kailash, tell me the difference between combinational and sequential circuits. Hello, Kailash.
Yes, sir.
Yeah, tell me.
Conventional circuit is as a no memory, and sequential circuit is a high memory, and conventional circuit is depends on a only input, and sequential circuit is depends on input as well as previous output. And conventional circuit there is no clock signal, and sequential circuit has a clock signal, provide a clock signal. Yes, sir.
Okay, tell me that some examples of the combinational and sequential circuit.
Sir, multiplexer, full adder, half adder, and decoder, encoder is a conventional circuit, and sequential circuit is a counters, uh, flip flops, and register.
Okay. So, okay, fine. Yeah, Garish, you can continue.
Okay. Fine. I'll ask one more last question to all of you. Kailash, do you know anything about the propagation delay?
Propagation delay. Yes, sir.
Yeah. Please answer. What do you mean by a propagation delay? Hello.
Sorry, sir. Can't remember. And,
Yogesh, the same question for you.
Not striking at the moment, sir.
Yes.
Yeah.
So propagation delay is the time taken by the system to reach input to output. Is to reach from input to output. That time taken. Yes, sir.
Okay. Yeah. Continue.
Yes, sir. Time taken by the signal to reach from so input to output is propagation delay.
Okay. What do you mean by slack?
Slack.
Hmm.
Yes. Skew slack. Yes. Clock is skew. Sorry, sir. I'm not remembering the slack definition right now.
Okay.
sir, slack is a required time minus arrival time.
See, that you are going for the setup slack. I'm just asking you to define a slack. What do you mean by a slack? Don't go with respect to the setup or hold.
Okay.
Just define slack. Because in industry there are many other types of slack going to be there. Not only setup slack and hold slack, there will be other type of slack, or there will be a simple slack also. So what do you mean by a slack? Define slack. Kailash, Yogesh, any of you?
It is a margin, sir.
What margin?
Means merging by which timing requirement is meeting or not meeting, like that. There are two kind of slack: positive slack and negative slack. Positive slack means your margin is higher than the required, while negative means your slack margin is lower than the required.
Okay.
Margin
If
it just means that this arrival time is minus actual arrival time.
Fine. Okay, I will come to your answer only. So if you have a positive slack, Avdesh, be on mute, please. If you have a positive slack, is it good for hold or setup? As per your answer, Yogesh.
Positive slack is good for setup or hold.
Hmm.
Positive slack is your signal is arriving late. If your signal is arriving late, means it is bad for setup time.
How?
Positive slack means your signal is arriving late.
Hmm.
So if your signal is arriving late, then it will be not the part of setup time violation, because signal is already arriving late.
So according to you, if the signal is arriving late, that is a positive slack.
Yes.
So you know that if okay, I'll ask you one more question. Define the setup time equation for me. Explain answer me the setup time equation.
Equation.
What setup time equals?
Setup time equal. I'm not getting equation, sir.
Required time minus arrival time, right?
Yes, sir. Required time minus arrival time.
If your required time is 5 and if your arrival time is 4, what is your setup time? Setup slack.
It will be 1.
Okay. So is it a +1 or -1?
It's a +1.
So it's a positive slack, right?
Yes, sir.
Then how will it violate your setup time? You said right, positive slack would violate setup timing. How will it violate your setup? It's contributing to the best of the setup, right? It is trying to bring the arrival data signal to arrive before the setup window. So it's coming 1 second early or 1 unit early than your setup window. So it's stable
Yes,
now.
sir. Yes, sir.
You said that positive slack would contribute to the worsening for the setup.
Yes, sir. I need to teach my knowledge on this setup
Fine.
and hold again.
Fine. Okay. I'll take one more question to all of you. Okay. You all are for DFT, right? DFT or DV? Sorry. DV. Okay. Fine. You have a block which is showing an error in your block. There is an error. For example, there is a block. There's a block which you don't know the internal circuitry. Okay, you are given an expected output which needs to be matching, but it is the functionality of the block is opposite to what your expected output is. What are the steps you are going to follow to rectify the output? I mean, rectify the circuit or try to rectify the output, make correction of the output. Starting with Yogesh.
So you have design verification. We have to think like a verification engineer. So as you are saying that your output is not matching with the golden reference kind of. So first you have to check that in scoreboard what you first you have to check the log file that where you are getting the mistake and all. Then you have to check that what you have did in scoreboard. Are you missing anything, or are you missing wrong data? And in log file you already detect that which signal you are getting wrong. So in scoreboard you will get to know that uh, which signal you are comparing with which golden reference. And after that we have to check that does you have written correct sequence, correct test sequence for that signal or not. So you have to follow this back tracing kind of mindset.
So, is there any other way to do the thing for Advesh and Kailash? Avdesh, sorry.
Sir, can you repeat once more? I'm not.
You have a blog which you don't know. You don't know the internal circuitry of the block. You have been given. You know a reference in output which needs to be present, but you are not getting the output as per your expectation. And what are the steps you are going to follow to make sure that the output is matched, and to identify the circuitry what is inside, or try to match the output? What are the steps you are going to follow to match the output?
So for that, I think I made the KMF for the golden reference, and will make the equation, and according to equation I will make the circuit, and after that I will see what is the problem with the circuit as the output with the output.
Okay. Go on mute. Okay, I'll go on mute. Go on mute. Yeah. Fine. Let's end this here. I'll give
Okay, I
a
will.
short.
Yeah, you can give the like feedback. I will take some questions from them. I will ask some very
Okay. Fine. For all of you, whenever you are attending a mock or at least a simple interview, also be prepared for that. I could sense that you are not up to the mark of preparation, and are lacking a lot of things. And whatever the questions I have asked are from digital, basic HTA, and even a basic DV questions and all. So you have to be prepared. First thing. Second thing, whenever you are sitting, make sure that you are sitting at a place where you are having at least a quiet background, or at least a silent or a pleasant environment, so that whatever you are speaking can be audible, and try to avoid too much of noisy environment. Okay, and the other thing is start to work from the basics, from digital to everything, because a lot of concepts are being misconcepted, and a lot of concepts are being like in a confusion state. Lot of concepts you really don't know, and you are not a first year engineering students to answer these questions, because as you go in the industry there are going to be lot of tough questions, or lot of industry standards questions being thrown at you. So you have to be prepared for that. You can't expect a basic question, what is the functionality of and, or what is the functionality of XOR, or what is the functionality of full adder. These people are not going to touch all of these. They are going to touch the very basics, or they are going to touch the industry standard questions. They are directly going to throw questions at you with the counters, marks, demax, flip-flops in digital. In STA, they are going to give you a problem with uncertainties, and they are going to ask you the reality questions. As I asked one, if you have a chip with a setup violation, can you use it or not? Actually, you can use a chip if you have a setup violation, but you can't use it at a desired frequency. You can use it at a lower frequency, which doesn't affect your setup violation. These are the things you have to consider. So yeah, try to understand, try to read a lot. You see, if you can't read a book, that's fine. You have a lot of PDFs on your mobile phones. Even you can contact Rajat, he will give you enough amount of notes for you. You don't need to hold a book and study. You can study on your mobile phones whenever you're traveling everywhere. Just try to analyze what the industry is, because industry is going as lesser technology as it can, like 3 nanometer. Right now we are in 3 nanometer. In future we'll go even less than 1 nanometer, and if you go with nanometer, then you'll go with the picometer technology. So if you have to be ready for that. Try to analyze everything and try to start again. There's no shame in starting from basics again. See, once if you are strong at basics, you will get the next things easily understood. Even though if you are working at somewhere, even though if you are worked at somewhere, that's okay. But that doesn't justify you that you know everything. Okay. The other thing is try to work on communication. You all need to work on communication. The easiest way is try to interact with someone. If not, try to watch some good English movies which has most of the vocabulary in that. Try to uh, add the subtitles and watch those movies. At least you can read and you can understand how the sentences are formed, what are the verbs, adjectives are used. Because whenever you are going to a corporate world, the only language that is used in the corporate world is English. You can't speak in Hindi, you can't speak in Kannada, Malayalam, Telugu, Tamil, Gujarati, Marathi, anywhere, because you are not going to be placed in your hometown to speak all those languages. So you have to learn one main language, that is English. So if you start to understand and if you start to speak, you'll get a better idea of it. So do these things. Start from basics. There is no shame in starting from basics. Once you get the basics, I'll bet on my words that you will try to catch all the upper concepts or all the higher concepts very easily in a minutes. That's what I'm saying. You know the higher level concepts, but you can't relate them to your ideologies or whatever you're thinking because you lack in basics. So try to refresh your basics and refresh everything. And whenever you are attending a mock interview or a simple interview, be prepared for the interview. Make some charts and stick on your walls. Try to read them, understand them, and then go with this. Okay. I hope you take these all feedback seriously and go for it. Okay.
Okay, sir. Thank you, sir.
Okay, sir. Thank you.
Yeah. So just
Fine. Thank you.
yeah, Girish, you can leave.
Yeah,
I will take the
Yeah, I'll leave.
yeah. Just
Okay.
everyone just turn on camera first. Everyone just turn on camera first. Yeah. So now Yogesh will tell me like why we prefer MOSFET over BJT in the like VLSI circuits. Why we prefer like MOSFET over BJT like in the VLSI circuits in the like basic circuitry.
Sorry, sir.
You can take 2 minutes time, no problem. Avdesh will tell you the okay. Avdesh, same question.
Hello, sir. MOSFET is a four-terminal device and BJT is a three-terminal device. And in BJT, there is a lot of power consumption, while in MOSFET, there is less power consumption in MOSFETs. In MOSFET, it works on two regions, linear or triode or saturation region, while BJT works in three regions: active region, saturation region, and switch cutoff region. So that's why MOSFET is preferred. And one more thing, MOSFET takes less space, less space, or we can say lesser in size than BJT. So that's why we prefer MOSFET over BJT in industry.
Some points are right, some points are like it is random. You just check it once, right? But at least you answered, right? So Yogesh, just try to answer whatever you know, right? It can be like basic thing about MOSFET you can tell, right? So
Actually,
it
sir,
should be
I'm
not
from
like I don't know, like it should be not like
actually, sir, from long time I'm
it's
connected to system
no
Vedlock and
problem,
UVM
no
only.
problem.
So
Okay,
I'm missing digital.
tell me one application of buffer. Kailash, you tell me one or two applications for the buffer.
Buffer is a sir, give up input as we get output is same, and buffer is a
Okay, next Yogesh, you will tell me the
So
application of
at
buffer.
the delay, we use buffer. Also, yeah, just kind of buffer memory means that A is equal to B. So here also we are using buffer memory. So for this purpose, we use buffer.
Avdesh, same question.
Yes, sir. Buffer is used as a delay element, and second one reason I am not able to remember at this moment.
Okay, okay. Uh, so, okay, tell me the difference between the blocking and non-blocking statement, Yogesh.
Blocking statement is if you are writing A is equal to B, this is a blocking statement, and the non-blocking means A less than is equal to B is a non-blocking statement. So in blocking statement, intra-delay and inter-delay both are additive, while in non-blocking, intra-delay is not additive, while inter-delay is additive. So this is the basic difference between this. Also, blocking delay we use for procedural statement, while non-blocking we are used for concurrent kind of statement. So this is the basic difference between this blocking and
Avdesh,
non-blocking.
you want to add something?
Yes, sir. Blocking this statement is used as the normal programming language as we assign something and it gives the value, it hand over the value at the same time stamp. But in blocking this statement, it executes at the same time stamp and after some time after the delta time delay, it gives transfers the value.
Okay, okay, fine, fine. Hmm. Okay, Kailash, you must tell me
Yes,
hmm.
sir, same question.
What? Yeah, same question you can tell me. Same question.
Sir, blocking statement is represent as equal, and non-blocking is represent less than equal. And blocking statement is used in a conventional circuit, and non-blocking statement is used in a sequential circuit.
That is generalized actually. That is generalized. It is not compulsory actually. Yeah, yeah. Tell me. Tell me next.
Sir, next, sir, बस
कितना नहीं पड़ेगा और काफी ज्यादा पढ़ना पड़ेगा तुम्हारा काफी रिव्यू खराब है फीडबैक.
सर रेडी नहीं था सर आज मैं बस अटेंड करने के लिए सर.
कोई नहीं, आप अब से तो समझ आ गया ना कैसे करना है.
हाँ ठीक है सर. ओके, नेक्स्ट टाइम से आई बेटर.
Okay, fine. Yogesh, tell me the what do you meant by LUT?
LUT.
LUT क्या होता है? LUT
Sorry,
पता
sir.
होगा.
In
FPGA. Okay.
sorry, sir.
Okay, Avdesh, you can tell me what's LUT.
Sir, actually, LUT is the full form of is the lookup table, and FPGAs in the ASIC, the circuit is converted into AND gate or gate on the and on the circuits. But in FPGA, all the circuits are converted into muxes, and muxes makes the LUTs.
Okay. Kailash, tell me what is jitter? Do you know jitter?
सर
नहीं पता. Okay. So how many gates are needed to implement NAND gate using NOR gate? You can take that pen और पेपर बना के भी देख सकते हो एक बार. NAND gate using NOR gate. बहुत सिंपल है. Yeah, योगेश पढ़ते हैं. What is jitter?
Jitter we get due to the it's a delay kind of we get jitter because of the temperature kind of issue. It means it's not a steady kind of delay. It is for only temporary moment. This jitter will get.
Okay, you need to just Google it. Yeah, Avdesh, just tell me.
Yes, sir. Jitter is a temporary variation in the signal.
Deviation basically. Okay, fine. Okay. Now we are coming to. Okay, Yogesh, which you have done I2C project.
Yes.
Basic idea, you know. Tell me which is better, I2C or what is the basic need of the I2C? I2C and Aspirant you are.
Okay, sir. It's basic need of it's a
Okay,
bidirectional communication kind of, sir. In I2C, we are only using SDA and SCL two lines, not more than. And while in SPI, you are using four lines like MOSI, MISO, slave selection, and clock. So this is the difference between this I2C and SPI. Also, mm,
yeah. What are the different signals in the I2C?
in I2C, only SDA and SCL. These are the signal. Both are bidirectional.
Okay.
Yes.
What are the different modes?
I2C different modes. Okay. Uh, uh, there are two modes in I2C: standard modes and and end time something kind of mode. Means that after completing transaction, I2C will be reading writing will be stopped. Sorry, sir,
Okay, you
little
have
bit
to
busy.
just go through. Okay, tell me what you do you know any one advantage of I2C over UART and I2?
Sorry, sir.
One advantage of I2C over UART and I2C. UART and I2.
In I2C, we need less wire compared to ESP.
Okay. Avdesh, Avdesh, you will tell me that
Sir,
you have done yeah. Tell me, Avdesh.
no, sir. That's why I.
Which projects you have done? FIFO have you not done?
Sir, I have not done FIFO and I done APB at the beginning. I will do
APB
it.
you have done.
Yes, I have. I have read about that
Okay,
the theory,
okay,
and I am reading I2C, SPI, and UART also.
okay. What is the like basic need of the APB protocol?
Yes, sir. The basic need of the APB protocol is to communicate with the low bandwidth and lower peripherals in the SOC. Low bandwidth peripherals.
Okay, Kailash, you have done any project? अच्छा एक क्वेश्चन
sir,
क्या है कैलाश को कैलाश
yes.
तो उसका आंसर क्या था
Sir, 4. Yeah, you NAND get implementing or NOR get is 4.
ओके फाइन ठीक है तो बना के देखा है अभी लाइक
Yes, sir. Yes, sir.
ओके फाइन ओके तो FIFO क्या है योगेश you have done FIFO project
Yes, sir.
okay tell me two difference between asynchronous and asynchronous FIFO two differences
Uh, if you have same frequency between two blocks, then that time you have to use a people synchronous. While if you have two blocks with having read and write different frequency, that time we use people asynchronous.
so which is better like which is better according to you like
Yeah, obviously
what
people synchronous will be better.
okay do you know about metastability and in which FIFO it exists
Metastability will get in the asynchronous people as your reading writing speed is not exact, so there is possibility of setup time and hold time violation, so you will get metastability.
Okay, what are the different steps to reduce the metastability?
To reduce metastability, you can use buffer inverter, um, and you add the delay for the purpose, or you just to avoid the setup time violation, you can lower your frequency. So in this way, you can reduce setup time violation and hold time violation.
Okay. So, Avdesh, you want to add something?
No, sir, I have no idea about FIFO.
Okay, sure. So which counter we use in the like asynchronous FIFO? Which type of the counters we use?
In asynchronous.
Yeah, in asynchronous FIFO में कौन सा counter use करता है?
Asynchronous counter, not clearly idea, but we can use asynchronous counter there also, which will not depend on asynchronous counter is not depend on clock, so I think we should use that thing. I will reprint my
gray code pointers here. We use gray code pointers.
Okay, sir. Okay, sir.
Just to avoid the metasploity. Okay, fine.
Okay, sir.
So anyone of you know about CDC?
Clock domain crossing we are using to avoid this metastability. Actually, this word is not striking to my mind.
Okay, no problem. Okay, Kailash, tell me the full form of FIFO.
First in, first out.
Okay, very good. At least you answered something. Okay, tell me difference between gray code counter and binary counter.
ग्रे कोड सर यूनिकोड होता है और बाइनरी कोड इज 2 बिट एंड ग्रे कोड इज 1 बिट.
Avdesh, you want to tell?
Yes, sir. Gray code is in gray code. The successive digits there is a 1 bit change in gray code. While in binary, there may be 1 bit changes also. Gray code is non-weighted code, while BCD is weighted code. And gray code is used to realize K-maps.
So, do you know about like body effect? Do you know about body effect?
Body effect, yes, in MOSFET. Yes. Yes, in MOSFET there is a N channel, gate, drain, and source, and the other terminal is the body. In general, drain is in N channel we use source, gate, drain. Yes, we connect a body to the source and the N channel. And if we consider body effect, there is the other parameters like gamma, BT naught, and the threshold voltage of the MOSFET is also affected based on the parameters, based on the equations. Gamma BT not equal. If we want to calculate threshold voltage after considering body effect, the equation is VT not equal VT equal to VT not plus gamma root of something like equation. I'm not remembering exactly.
Just check it out. So Yogesh will tell me that like 2 differences between Verilog and VSDL.
Verilog and VSDL. Sorry, sir, I have not gone through VSDL.
Tell me like advantage of system Verilog over Verilog.
In system Verilog, you can verify your circuit thoroughly, sir. While actually system Verilog is just an updated version of Verilog. In system Verilog, you have oops concept kind of things which is not present in Verilog. So so this thing giving system Verilog highly advanced technology compared to Verilog.
So what is the advantage of oops in like system Verilog?
Just because of you're doing oops means the object oriented program, so in this you can use classes, so in future you can extend it. So basic property, keeping basic property, you can add some additional property also. So reusability purpose, system verilog is more useful compared to this verilog. Also in this constraint term also in the system verilog, which is by this you can discipline your randomization function, while in verilog only random function is there. So if you want to what to say, if you want to cover the corner cases, so system verilog will be very useful compared to uh, plain verilog, because in system verilog you are using constraint. By constraint you can cover all the corner cases. So system verilog is
Just check it once.
more
Just check it
beneficial
once. That
than
is a note to the mind. Like it is like 40% fine, but it it more points you can add at least, right? Okay. So anyone want to like tell the architecture of system environment, TB environment? Abdesh, you want to tell the like basic flow?
Yes, sir. I know the basic flow.
Yes, sir.
In the system Verilog verification environment, first of all, we create the class transaction. In the after declaring duty and interface, we make the transaction class. In transaction class, we use the interface signal only with the input and output, and we declare them either or bit or logic type depending on the requirement. And after that, we make the generic display function we, to display the values at different stages in the forthcoming stages. We make a generic display function, and after that we make the deep copies. We make the deep copies of the signals, input output signals, which are declared in the transaction class, and where transaction classes sum up. And after that we create a generator. In generator we use randomization and constants to generate the different stimulus, and those stimulus the randomized stimulus are provided to the driver, and we compare those inputs with the reference model declared in the driver. And after that we come to the monitor. The monitor takes the outputs from the driver and displays whether they are matched with our reference model or not. And after that we go to the environment. In environment we call the generator, driver, monitor, and after that is the end of the flow.
Okay, fine. There is concept of mailbox. Like what is that?
Yes, sir. Can you repeat?
Mailbox.
Mailbox. Yes, mailbox are used to communicate between the classes and between the blocks. To get we use two mailboxes in in the whole architecture, from generator to driver and driver to monitor. The mailbox is used here to communicate for communication of the signals.
Okay.
The test bench architecture of the
And what is semaphore?
semaphores. Less idea about semaphores. Sorry, sir. I will get that next.
Yogesh, you want to tell me what fork and join?
yes, sir. Fork join is basically concurrent kind of statement. It means if you are there are three types of fork join statement, like fork join any, and fork join none. So if you are if you are writing something in fork join, so it will processor will wait to complete or statement belongs to foreign statement. Only after completing foreign statement it will go to parent component. While in foreign any if any one of the statement is executing in foreign any, then it will be then it will passing to the out of the foreign block. While in foreign non, it will not wait to execute the foreign non-block statement. It will go out of the foreign block at the moment only. So this is the difference.
Okay, fine. Okay, so should we end the meeting? Like, या काफी ज्यादा इम्प्रूवमेंट की जरूरत है तीनों को ही, या कैलाश को तो बहुत ज्यादा जरूरत है, ऐसा लग रहा है किसी कुछ पढ़ा ही नहीं है ना? तो बहुत ज्यादा जरूरत है। योगेश, तुम्हारा लाइक तुमको चीजें आती हैं लेकिन रिवीजन नहीं करोगे तो यही सीन होगा, है ना? तो और अवधेश का अब अभी इम्प्रूवमेंट करने की जरूरत है। मॉक इंट्रो देते रहोगे तो इम्प्रूवमेंट होता रहेगा, मॉक इंट्रो नहीं दोगे तो सब कुछ भूल जाओगे।
Yes, I will improve every day. I will give every day.
हाँ, टाइम टू टाइम मॉक इंट्रो देते रहो ताकि चीजें रिवीजन जल्दी करो और सिलेबस को जल्दी से कंप्लीट करो।
Okay, sir.
योगेश, जस्ट ट्राई टू रिवाइज एवरीथिंग, राइट?
Yes, sir.
अभी मेरे को यही लग रहा है कि तभी वहीं पे रहती है कि तुम पास ऑन कर जाते हो क्वेश्चन, है ना? ऐसे नहीं करते, पास ऑन नहीं करना है। जितना भी चीज उसके बारे में पता है बताते हैं इंटरव्यू को, है ना? तो वो वाला पॉइंट मिसिंग है। तो आती हैं चीजें, लेकिन इंटरव्यू में यही बात है कि तुमने रिवीजन अच्छे से नहीं किया चीजों को, बेसिक चीज भी नहीं आती है, तो उस चीज को इम्प्रूव कर लो, हो जाएगा, है ना? और कैलाश जस्ट पहले सिलेबस कंप्लीट करो और टाइम टू टाइम मॉक इंटरव्यू देते रहो, और अभी मत दो, पहले सिलेबस कंप्लीट करो, है ना?
Okay.